Hello everyone. It's definitely taken me longer to get through this packet of notes than I had originally anticipated. So, but this should be the last video on these notes. I think this is video 4, the 4th video. But before we move on to the last, or page 6, I'm going to revisit this example that we did at the end of the previous video. And I'm going to show you an alternative way of solving this problem. In trigonometry, there are multiple ways a lot of times to solve a problem. Okay? And so I'm going to show you an alternative approach to solving this problem using the fundamental identities in on the previous pages. Fundamental identities on page 4 of your packet. So we're given sine theta is equal to 3/5 and the angle theta is in quadrant 2. Well, one of the identities on page 4 is the Pythagorean identity sine theta squared plus cosine theta squared is equal to 1, right? So you know this, how this is read is sine theta quantity squared plus cosine theta quantity squared is equal to 1, right? That's how that's read. Well, if I put in 3/5 for sine theta, I have 3/5 squared plus cosine theta squared is equal to 1. Well, 3/5 squared, right, is 3/5 times 3/5, which is 9/25. And now, right, I'm solving for cosine theta. When I subtract 9/25 from both sides, I get cosine theta squared is equal to 16/25. 1 minus 9/25 is equal to 16/25. And now you know square root undoes the squaring. And so when I take the square root of both sides, I have the square root of cosine theta squared equal to the square root of 16/25. But now remember, theta is in quadrant 2. And from our discussion on the sign of the trigonometric functions on page 3, we know that if the angle theta is in quadrant 2, the cosine of that angle is negative. And so cosine theta is going to equal the negative of the square root of 16/25 because this angle theta is in quadrant 2. And so on the left, we just have cosine theta. And on the right, we have square root of 16 is 4, square root of 25 is 5, and so we just have minus 4/5. And so that was one of our answers from the approach, the first approach we used to solving this problem. Well, we immediately know that the reciprocal, right, cosecant theta is the reciprocal of sine, and the reciprocal of 3/5 is 5/3. So, as in the previous example, approach to solving this problem, we know that cosecant theta is equal to 5/3. Because cosecant is the reciprocal of sine, and the reciprocal of 3/5 is 5/3. Secant is the reciprocal of cosine, and the reciprocal of minus 4/5 is minus 5/4. So just as in the previous example, we immediately know that the secant theta is equal to minus 5/4. And then that just leaves a tangent cotangent to find. Well, tangent theta from our fundamental identities is equal to sine theta over cosine theta. Well, sine theta we're given as 3/5. Cosine theta is equal to minus 4/5. And when you divide those two fractions, since they have the same denominator, right, the 5's cancel, and what are we left with? Minus 3/4. And so we immediately know that tangent theta is equal to minus 3/4. As in the previous approach to solving this problem. Cotangent theta, we know is a reciprocal of tangent theta, and the reciprocal of minus 3/4 is minus 4/3. So this actually turned out to be faster, I think, in solving this problem. But you can't lose sight of the fact that in quadrant 2, okay, if theta lies in quadrant 2, the cosine function has a negative value, not a positive value. So you take the negative of the square root on the right-hand side, not the positive of the square root. So this is actually, I think, faster. Just got to be careful to remember what the sine and cosine is. Okay, so in trigonometry, right, and a lot of times there's like 1,000 ways to approach solving a problem. Okay, more than one way to skin a cat, as the old saying goes. All right, so if you flip over to page 6, we're going to talk about the even and odd properties of the 6 trigonometric functions. Some trigonometric functions are even, and some trigonometric functions are odd. Well, as it turns out, only 2 of the 6 trigonometric functions are even functions. It's cosine and it's reciprocal secant. And then all the remaining trigonometric functions are odd. Sine, cosecant, tangent, and cotangent. So what do we mean by a function is even or a function is odd? Right? A trig function is even or a trig function is odd. And the best way to do this is just to demonstrate with an example. Okay? Cosine of minus 45 degrees. Because cosine is an even function, that means we can just drop the minus sign in front of the angle, and the cosine of minus 45 degrees has the same value as the cosine of plus 45 degrees. And from the unit circle, we know that the cosine of plus 45 degrees is equal to square root of 2 over 2. So when you're taking either the cosine or the secant of a negative angle, you just can drop the minus sign and take the cosine or the secant of the positive angle. With the odd property, right, sine is an example of an odd trigonometric function. Here we're taking the sine of minus 30 degrees. We don't drop the minus sign in front of the angle. What we do is we got to move it out front of the trigonometric function. So the sine of minus 30 degrees is equal to the negative of the sine of plus 30 degrees, right? The minus sign was brought out front of the sine function. Well, the negative of sine 30 degrees, right, that's an invisible minus 1 up front. That's the same as minus 1 times the sine of plus 30 degrees. And from the unit circle, what's this sine of 30 degrees equal to? It's 1/2. So minus 1 times 1/2 is equal to negative 1/2. So using the odd property, right, for the sine function, the sine of minus 30 degrees is the same as the negative of the sine of plus 30 degrees. And when we replace sine 30 degrees with 1/2, we get minus 1/2. So we know the sine of minus 30 degrees is equal to minus 1/2. Okay? So in the exercises down below, we're going to use the even and odd properties to find the exact value of each trigonometric expression. So in the first example, we have the sine of minus 60 degrees. And so since sine is an odd function, we bring that minus sign out in front of the sine function, right? So this is equal to the negative of the sine of 60 degrees. That's a minus 1, so this means minus 1 times the sine of 60 degrees. And from the unit circle, the sine of 60 degrees is root 3 over 2. So this is minus 1 times root 3 over 2, which is just a negative root 3 over 2. I put in a lot of extra steps. If you were solving this problem on an exam, you could just go from here to here to here, okay? But I'm throwing extra steps in there. Cosine minus 30 degrees. Cosine's an even function, so we just drop the minus sign in front of the angle, and we have the cosine of 30 degrees. And from the unit circle, we know that's equal to root 3 over 2. So the cosine of minus 30 degrees is equal to root 3 over 2. The tangent of minus 45 degrees, tangent is an odd function, so we've got to bring the minus sign out in front of the tangent. And so when we do that, we have the negative of the tangent of 45 degrees. Right, so this is an invisible minus 1. Well, tangent 45 is equal to 1. Maybe we'll write it out. This is minus 1 times the tangent of 45 degrees. And we know that the tangent of 45 degrees is equal to 1. So this is minus 1 times 1, which is equal to minus 1. So the tangent of minus 45 degrees has a value of minus 1. The sine of minus pi over 6, well, sine's an odd function. Right, now we're dealing with radians, okay? So we got to bring the minus sign out in front of the sine function. And so the sine of minus pi over 6 is equal to the negative of sine pi over 6. And sine pi over 6 in the unit circle is equal to 1/2. So this is equal to minus 1/2. Cosine minus pi over 4 radians. Cosine is an even function, so we can drop the minus sign in front of the angle. And so this is equal to the cosine of pi over 4 radians. And you know from the unit circle, cosine pi over 4 is equal to square root of 2 over 2. And lastly, tangent of minus pi over 3 radians. Again, you know that tangent's an odd function, so we got to bring the minus sign out in front of the tangent. And so this is equal to the negative of tangent pi over 3. And tangent pi over 3 is equal to square root of 3. So this is equal to minus root 3. So the tangent of minus pi over 3 radians is equal to minus square root of 3. And we're done, okay? So that's how you apply the even and odd properties to the trigonometric functions, okay? If it's, for those for cosine and secant that are even functions, we just drop the minus sign in front of the angle. And for those that are odd, we got to bring, that are odd functions, we got to bring the minus sign out in front of the trigonometric function. On page 7, it talks about the domain and range of the 4 trigonometric functions: sine, cosine, tangent, cotangent. I'll let you read that on your own, and we will discuss it in class when we talk about section 2.5, okay? Or 2.4, sorry, 2.4, okay?